Hi guys, welcome to another wonderful day of learning online. Hope you guys are all doing well. We are moving on to our next lesson in our limits unit. This is evaluating infinite limits. So let's just start out with a do now problem, kind of reviewing what we talked about in our lesson from Monday. So I want everybody to take a moment right now, maybe a minute, and try and answer this question. And we'll come back in a couple of seconds and see how you did. Okay, did you guys all get -7 like I did? Hopefully, fingers crossed. When we plug in originally, we get that 0 over 0 right here. And so then I came over here. And as we've done when we get 0 over 0, we factor all components. I could only really factor the numerator. The denominator stayed as x plus 5. I saw that I had a common factor of x plus 5 in both the numerator and the denominator. So I'm able to cancel that factor out, and I'm just left with x minus 2. And when I'm just left with x minus 2, we're going to reevaluate that limit as x approaches -5 of our now simplified function. So when I plug -5 in for x, -5 minus 2 is -7. Hopefully you guys agree with me. All right, moving on. So today, please make sure, side note, again, you're taking notes while I'm going through this like you would in class. Thanks. Okay, so recall, just like we did in our do now, if you plug in an a value that, generally if we write the limit as x approaches a of f of x. So if you plug in that a value to get the limit, that's what we always want to do first, plug in. If you get 0 over 0, we have to factor, cancel out the common factors, and then replug in. This is when we get a point discontinuity. So if you get 0 over 0, that means on your graph, your function could look something like this. You just have that hole in your function somewhere, right? That's called a point or removable discontinuity. That's what's happening when you get 0 over 0 when you plug in. But there's another possibility. If you plug in and instead of getting 0 over 0, you could get a number over 0. So let's say you got 4 over 0, -2 over 0, 10 over 0. That is no longer a point discontinuity, that is an infinite discontinuity. And an infinite discontinuity was when we had our vertical asymptotes. All right? So if we get a number over 0, that means that we have some sort of vertical asymptote that we are dealing with. And so we got to go through and talk about what those steps are going to be in order to answer that question, because they're not going to be the same process as the 0 over 0. All right, we're no longer going to be able to factor the numerator to cancel something out, so we need different steps. But before we talk about those steps, let's talk about our 3 possibilities for infinite discontinuities. So the first one is that if I have some sort of vertical asymptote, I could have both sides of my function going up towards positive infinity. All right, and so that means if I take the limit as x approaches, I'm calling this my a value, right? If I'm approaching that x value of the function, both the left side and the right side are approaching the same thing. They're both approaching positive infinity. So if this is the case with my graph, if the left side and the right side are both approaching positive infinity, that means my overall limit exists, and it exists at positive infinity. All right, well, I could have another circumstance where both the left side and the right side are going down forever, approaching negative infinity. So that means that if I have the limit, wow, that was really messy. If I have the limit as x approaches a of f of x, right, the left side and the right side, again, are both approaching the same thing. So when the left side and the right side are approaching the same thing, the overall limit exists, and this overall limit is going to exist at negative infinity. because that's where both sides are approaching. They're going down forever towards negative infinity. Now, my last option is when x approaches a, I could have the left side going in one direction and the right side going in another direction. Now, I could draw this either way. I could have also drawn this where, just quickly sketching this over here, where the left side was going down and the right side was going up. Right, these two are pretty much interchangeable. I'm just pretty much showing that the left side and right side are not approaching the same y value anymore. So in this case, if we take the limit as x approaches a, that's supposed to be an a, sorry again, my messiness, of the function. So if we're approaching that vertical asymptote, that means the left side and the right side do not approach the same thing. Therefore, my overall limit does not exist. Now, it's super important to understand that when you get a number over 0 after you plug in, the only answer choices for your final answer are going to be positive infinity, negative infinity, or it does not exist. It is not going to be possible to get like 2 as your answer, or 5, okay? These 3 graphs are the only possible outcomes for when you plug in and get a number over 0. Because when you get a number over 0, that means you have a vertical asymptote, and these 3 are the only, I should say 4, these 4 are the only graphs that you can get with a vertical asymptote. Therefore, these 3 answers are the only possibilities when you plug in and get a number over 0. So be very careful of that. Make sure you're writing that down in your notes, that when you plug in and get a number over 0, you are never, ever, ever, ever going to get a numerical value for your answer. You are only ever going to get positive infinity, negative infinity, or does not exist. Okay, so let's go on and talk about those steps now. All right, so first problem that we're going to deal with is if I have the limit as x approaches 0 of 4 over x squared. So going back to our steps, again, step 1 is always plug in. Right? So they're the same steps that I showed you on one of the past slides. We always want to plug in first. Now, if I plug in, I'm going to get 4 over 0. So that's that number over 0. That means I have a vertical asymptote. Step 2, we use, sorry, it's a little small. Step 2, we use if we get 0 over 0. Well, we didn't get 0 over 0 when we plugged in. So that means I'm going right from step 1 to step 3 because I got a number over 0. Okay, so first thing I'm going to do is I'm going to show you how to answer this problem. And then on the next page, I'm going to have written out steps for you to write down. Okay, so again, I'm going to go through and show the problem first. And then on the next slide, there will be written out steps that you should pause the video and copy down at that time. All right, so what do? If we get a number over 0, we're actually going to split up the limit. So instead of looking at the limit as a whole, we're going to look at the left-hand limit versus the right-hand limit. Okay, so we're looking at the left hand versus the right hand. And I just want to know, are they both going in the same direction, or are they going in 2 opposite directions? All right, well, how do we do that? So I am going to choose, for my left-hand limit, I'm going to choose a value directly to the left of 0 on my number line. Why am I choosing 0? Because 0 is my original x value that I'm looking to approach. So what is a number directly to the left of 0 on the number line? Well, that would be if x equals -1. So what am I going to do with that? I'm now going to reevaluate my limit, and I'm going to find just the left-hand limit as x approaches 0. And the way I'm going to do that is I'm going to plug in this value of -1. So into my function of 4 over x squared is going to go my -1 value for x. So that's going to give me 4 over a +1, which is 4. Okay, I'm going to pause there for a second, do the right-hand side, and then I'm going to come back and explain how we find our final answer. Okay, right-hand side, same thing. I'm going to choose something now directly to the right of 0 on the number line, which would be x equals 1. So I'm going to evaluate now my right-hand limit only. And so into my original function, I am plugging in +1. And so that's going to give me 4 over 1, which is 4. Now here is the big thing. The left side and the right side say they're both approaching 4. My answer is not 4. The overall limit does not approach 4. Remember, when we got a number over 0, that means that we only have those 4 graph options. They're either both going up, they're both going down, or they're going in opposite directions. So I'm just trying to figure out which one of these 4 options do I have. Well, so instead of looking at this 4 as a number 4, I look at this that this is a positive value. So if I have a positive value directly to the left of 0, that means that my left-hand limit is going to be getting more positive as I get closer and closer to 0. Then I go over to the right-hand side. And again, I'm no longer looking at this 4 that it's 4, but again, I'm looking at it that it's a positive value. And so if that's also a positive value, that means that my function is getting more positive as it gets closer and closer and closer to x equals 0. So if both sides are going up and up and up and up and up forever to positive infinity, that means that my overall limit, back to that original problem, my overall limit is going to positive infinity. The left side and the right side both got me positive values, so that means that my overall answer is positive infinity. Okay, if the left side and the right side were both negative values, then both sides would be going towards negative infinity, and that would be my answer. If one got me positive and one got me negative, then I would be writing that my overall limit does not exist. All right. I know that was just the first example. We'll go through a few more. I know I said I was going to post the steps on the next slide. However, I realized because I brought over these slides from one of my, Smartboard presentations, I can't add in a new page until the end. So I apologize for this, but all those steps, we're going to continue on with our practice problems, and then the steps for solving this will be on the last slide after I finish with all the practice problems. Okay, so again, I'm sorry for that miscommunication before. The slides will be at the very end. All right, let's go to our next problem. So the second problem that we're going to talk about is if we have the limit as x approaches 2 of 2x plus 5 over x minus 2. So again, first thing, step 1 is plug in. So after I plug in the 2, I see I'm going to get 4 plus 5 over 2 minus 2. So that's going to be 9 over 0. So again, I don't need step 2 because I only use step 2 if I get 0 over 0. So I'm going right to step 3, which is what we use when we get a number over 0. All right, so same thing that we did last time. We're going to split this up into a left-hand limit and a right-hand limit. And so since x equals 2 is what I'm initially approaching, right, so I'll just kind of write x equals 2 here. Directly to the left of 2 is x equals 1. And directly to the right of 2 is x equals 3. So those are the two x values that we're going to be plugging in to find our left-hand and right-hand limit. So I'm going to evaluate my left-hand limit. And so that means that I'm going to plug in 1 into my original function. And so 2 plus 5 is 7, 1 minus 2 is -1. So this is a negative value overall, right? I don't necessarily need to know that it simplifies to -7. I just need to know that it simplifies to a negative value, because what does that tell me? That means that the left side, to the left of 2, my function is going down, 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 getting more negative. Now, if we flip over to the right-hand limit, if I find my right-hand limit as x approaches 2 of the function, now I'm plugging in 3 into the x values for that original function. And so I'm going to get 6 plus 5, which is 11, over 3 minus 2, which is 1. And again, I don't need to know that that overall simplifies to 11. I just need to know that that overall simplifies to a positive value. So that means the right-hand side overall is getting more positive. So if the left side's getting more negative and the right side's getting more positive as we approach 2, that means that we are not approaching the same value. So along my vertical asymptote, the left side is going to negative infinity, the right side is going to positive infinity. So that means that my answer, the overall limit, does not exist. All right, cannot exist if they are approaching 2 different values. Moving on, example 4. All right, we are going to see the limit as x approaches -3 of x squared plus 6x plus 9 over x minus 3. So step 1, as always, plug in. And when I plug in, we are going to get -3 squared, which is 9, plus 6 times -3, which is -18, plus 9, over -3 minus 3. So this is going to be -9 plus 9 is 0, and -3 minus 3 is -6. All right, well, which step do I go to? Did I get 0 over 0 to do step 2? No, that's not 0 over 0, so I don't have to do step 2. Does that automatically mean I have to do step 3? Step 3 is when I get a number over 0. Did I get a number over 0? No, I did not get a number over 0. I don't have to do either one of these steps. Why? Because this number right here is not a discontinuity. You get a discontinuity when the 0 is in the denominator. Where's the 0 in this case? The 0 is in the numerator. So if you have 0 divided by -6, that means your answer is just 0. You don't have to do anything further. This is back to day 1. All we had to do was plug in. We plugged in, we got a value, that value was 0. Done. Misconception. Don't automatically think just because you have a fraction that you're going to have to do the 0 over 0 or the number over 0 process. Okay? Sometimes you plug into the fraction and you just get out a number. Okay? Also, don't mistake 0 over a number for a number over 0. Not the same thing. Okay? If the 0's in the numerator, your answer is 0. If the 0's in the denominator, that's where you have an issue. That's where you have a discontinuity. That's where you have to do one of these 2 steps. Okay? But for this one, not needed. Okay, let's go to another example. All right, so we are going to now have the limit as x approaches 3 of -x squared over x squared minus 6x plus 9. All right, step 1, plug in. Be careful, when you have negative times negative x squared, that means you are squaring the 3 value first. And then you are negating it afterwards. Okay, so in this case, you do end up with just -9 over 0. Okay, because again, you're just squaring the x value first and then you're negating the result. So again, step 2 not needed. That's only if you get 0 over 0. Step 3 I'm going to have to do. So let's split up our limit. Left hand and right hand. So I'm approaching 3. So that means my left hand limit just to the left of 3 is 2. And just to the right of 3 is 4. Okay, so I just kind of went ahead and plugged in all of that information. So if you want to copy it down and take a minute, you can pause the video to copy down my work. But we've got our left hand limit as x approaches 2. And so when we plug in 2, we're going to get 2 squared, which is 4, and then negate it in that numerator. So negative 4 on top. Denominator, you're going to end up with a 1. So overall, you have a negative value. So that means your function is getting more negative as x approaches 3. For the right-hand limit, we're plugging in x equals 4. So 4 squared is 16. Negated is negative 16 in that numerator. And we end up with 1 in the denominator. So again, we end up with another negative value. So my right-hand limit and my left-hand limit are both approaching negative infinity. So that means that my answer, my overall limit here is negative infinity. That's going to be my final answer for that question. Okay, so now I would like you guys to try out this problem. Now I am warning you, this is going to be a little different than any of the problems that we've just done ourselves. Okay, there's a little bit extra going on here, but I want you to look at this problem. Okay, take a couple of minutes, try it out, and see if you can get to the final answer. All right, so I'll check back in a little bit. Okay, so, well, I'm not fully done yet, but if I plug in initially, because that's what we always want to do first, we always want to start with plugging in, I see that I get 0 over 0. Now, that's not what we talked about today. That's from what we talked about on Monday. 0 over 0 means that we have that point discontinuity, so we are going to factor. So I factored the numerator and denominator. I saw that x plus 3 was a common factor for both, so I canceled those out. And then I came back over here and reevaluated my new limit with the simplified function like we're supposed to do, like we were taught on Monday. And what happens? I get a number over 0. That's not what's supposed to happen. I don't like that. Well, if you plug in and get 0 over 0, you factor, and then you plug in and get a number over 0, that means that you actually don't have a point discontinuity. You have an infinite discontinuity. You have that vertical asymptote. So what does that mean? That means that we're going to have to come right back over to our left hand and right hand limit, and we're going to have to do the process from today, and we're going to end up with only positive infinity, negative infinity, or does not exist for our answer. All right, so now take another minute, finish this out, and see whether you get positive infinity, negative infinity, or does not exist. All right, so final answer is that the limit does not exist. If I plug into the left hand and right hand, okay, the left side is approaching positive infinity, the right hand is approaching negative infinity. Now, just one of those be careful moments, x equals negative 3. That's the value that we are approaching now on a number line. To the left of negative 3 is negative 4. To the right of negative 3 is negative 2. There are people out there that will flip that, and they automatically just think, oh, 2 is less than 4. So they use 2 for the left-hand limit and 4 for the right-hand limit. Just be careful of that. Okay, left-hand limit always has to be the smaller number. Right-hand limit has to be the larger number. Also, another thing, when you plug in, you don't have to go back to that original function. You can use the simplified function that we had after we canceled out that common factor of x plus 3. So don't think you have to go all the way back up here to this original function. Definitely use the simplified version to help you out. All right, and again, we end up with the left side approaching positive infinity, the right side approaching negative infinity, and so that means my overall limit does not exist. Okay. All right, well, that is the end of the lesson for today. As I said, in a moment, on the next slide, the steps will pop up. Hopefully you guys are kind of getting it from just visually watching me, but I am going to have those steps written out for you to copy down at the end of this lesson, okay? Hope everybody's doing well, and see you all soon.